daily class, today we're going to have a short lecture on water closets. So water closets are one of the soil fixtures which is included in your plumbing system. So water closets are divided into according to the following types. So we have what you call flush tank water closets. It's according to flush tank water closets. Then you also have the direct flush valve water closets. So flushing action can be obtained directly from a flush valve connected into the bowl. Then you also have according to the flush tank type. So there are different flush tank types. One is we have the integral flush tank. Two, we have the coupled flush tank. Three, we have the low flush tank. The fourth one, you have the high flush tank. Then when it comes to according to mounting, it's separated into the wall mounted type and then the wall hung type. Okay. So if we categorize water closets according to flushing action, it could be a wash down or it could be a reverse trap. So when you say wash down, it flushes through a simple wash down action, discharging waste in the trapway located from the bowl, has a bulge on the front, has a small amount of standing water, then costs less but is as less efficient and the noisiest. Then you have what you call the reverse trap, which flushes through a siphon action created in the trapway. So the trap is located at the front, hence the term reverse. So this is the example. Now, if you look at this setting class, it says that the water closet centered on the side wall with a minimum of 0.375. So if this is the side wall class, you should have at least 0.375 distance. Okay? Then the distance from water closet to water closet should be around 0.75 meters. But I don't think that this is without a partition. Just imagine two people sitting down at a distance, at this distance. It would be quite intimate. So don't forget to place a thin wall or divider in between them for privacy. Okay? Now let's go back to the water closets according to flushing action. Okay? From the reverse trap, we also have what you call a siphon jet water closet. Here, siphon jet, which is a larger trapway, making it less likely to clog. So it is a quieter flushing action and it retains a large amount of standing water. Then we have siphon vortex. Here, this is the example of the siphon vortex. It is less noisy and very efficient. So flushing action is started by a whirlpool motion, followed by a complete flush down. So it retains a large amount of standing water. Then we have a direct flash valve. So the flushing action is obtained directly from a flush valve connected to the valve. Okay, so let's go down. So these are the different types. I hope you'll remember. If you're going to uh, categorize water closets according to flushing action, you will remember that it's either a flash down, reverse trap, siphon jet, siphon vortex, or a direct flush valve. Okay? Now let's move into the next type. Okay? So there are also what you call a squat type water closet. So this is something that I have experienced that is very common there in the Middle East. Okay? I don't know if you are a familiar class with the study that I think that it is healthier for human beings to squat while doing their thing compared to sitting down. Okay? So this is a washout type water closet. Okay? So this is the typical section. Here we have the float rod. Then we have the float ball. Okay. If you can look into the water closets in your home, I think it would be best if you locate these components or parts of the water closet. So I have here the flush ball. You have here the tank outlet. Then you have the bulk assembly or flush valve. Then you have here the spud washer. Here at the bottom, we have a wax or rubber seal. Then we have a flange bolt and you have a closet flange. So these are the different parts. Okay. So I think you should also research this on other sources as well. Um, I think if there might be new technologies which are more innovative than the basic layout section of a typical water closet. So what's important to remember, class, that when you design buildings, okay, so this is referred to the National Plumbing Code, is you remember in your design uh, to consider the number of water closets that you are going to place. So if you are in a dwelling or apartment, there's a family, there's a for every family there's one water closet. So if your apartment buildings has, let's say, 200 units, so you should expect that there should be 200 units of water closets. So that's as per national plumbing code. So in elementary schools, for every 1 to 20 persons, there should be one water closets. So if it's more than 20, but from 21 to 50, so there's two, then there's an additional one water closet per person. Then for assembly places such as theaters and auditoriums for public use, remember that for every 1 to 100 males, you need one water closet. Then from 101 to 200, you need around two. Then when you reach already a capacity of 201 to 400, there should already be three. Okay? So remember this one. Then if for 1 to 50 females, there should be three water closets. Okay? So if you look at the data class, you can see that females, I think they need to have a more water closet ratio compared to males. Because if it's 1 to 100 males, you only need one. Well, for every 1 to 50, you need three. Okay, so those are the things that you must consider. Of course, class, when you already do your buildings, for example, in your thesis, you must have an idea on how many males, females, or how many persons will be using that building or facility through statistics. Okay, then for 51 to 100 females, there should be 4. For 100 to 101 to 200, that's more than 100 already, you have 8. Then per additional 500 males over 400, this should be 1. Then per additional 300 males, females over 400, there should be 2. Then if you do dormitories, per 10 males, there should be 1. Then per 8 females should be 1. Then per additional 25 females and 20 females, 25 males and 20 females, there should be one water closet. Okay, so remember and try to familiarize yourselves with this data class because this is important, especially when you design already. So when you reach higher design, you should have a reason why on the number of water closets that you are providing. So hence we have a plumbing subject. It would be quite nice if you can memorize this data, but I think you just forget about it. So what's important right now is you familiarize this data for the next few years. Then I think you can successfully apply this in the board exam or in your practice someday. Okay, so let's move to the next slide. Okay. Then for the industrial, so when you reach your professional practice 2, we're going to have a list of building types in accordance with our professional practice document, SPP documents. Okay? So when you do industrial designs, per 1 to 10 persons, you need one water closets. If it's already 11 to 25, you already need two. When you reach 26 to 50, you need three. For 51 to 75, you need four. For 76 to 100, you need five. Then per additional 30 persons in excess of 100, you need one. Okay? So these are the types of urinals. First is we have the wall hung type, which is the most common type of urinal. Okay? So I think the males in our class are already familiar with this one. So these are mounted to the wall and equipped with direct flush valves and integral or exposed traps. Okay, so when you go to the malls and if you go to the movie houses, um, you could notice that it's already sensor based. Okay, so after you urinate, and it will automatically flush. But in older models, you have to push the button here. Okay, so I encourage you guys to always bring your small alcohol spray so that you'd have a sanitary lifestyle when you use these public uh, type of urinals. Then you have the pedestal type. So it's the most expensive type. So these urinals on a pedestal make use of direct flush valves and integral traps. Then you have a through urinal. So market versions come in the form of a tub. Local version can come in different forms. So usually with a perforated water-filled pipe and with drains at the floor level and traps underground. Then you have a stall, which is a large tall urinal built to the wall. Not recommended because large surface is more prone to fouling. So usually with direct flush valves, but older versions have overhead tanks. Okay, so let's go down. So from the urinal center to the sidewall class, when you design, there should be a minimum of 0.30 meters distance. Then from urinal center to center, it should be at a distance of around 0.60. Okay, so I hope you can remember these design standards when you design. Of course, class, center to center urinals, there should be some form of barrier in between. Okay. I think, class, when you design your restrooms, you should be wary in placing windows. No, not windows, in mirrors. In placing mirrors, because sometimes I've noticed that designers, um, if the urinals are located here in an array, then you have here the divisions. It's directly facing a mirror, so there's no privacy. Imagine you urinating here, then at your back there's a huge mirror reflecting your back. So there's no privacy in it. So that's why when you design class, always consider the human side in designing. So that's it. Then for flushing through urinals will be done through automatic flushing tanks. That's per National Plumbing Code 408.1. Then flushometer valve shall be self-closing type, discharging a predetermined quantity of water. Then no manually controlled flushometer valve shall be used to flush group urinals according to the National Plumbing Code. Okay, so these are the minimum uh, requirements. So for schools, either elementary or secondary, there should be one urinal per 75 meals for the elementary. For the secondary, there should be one urinal per 35 meals. Okay. Then for an office or public building, for every 1 to 100 meals, there should be one urinal. 101 to 200, there should be two. 201 to 400, there should be three. 401 to 600, there should be four. And for each additional 300 meals, there should be at least one. Okay? Then for assembly places such as theaters and auditoriums for public use, there should be one urinal per 1 to 100. Then from 101 to 200, there should be 2. From 201 to 400, there should be 3. From 401 to 600, there should be 4. Then for each additional 500 males, there should be 1. Then for dormitories, per 25 males, there should be 1. Then per 50 males in excess of 150, there should be 1. But for industrial and commercial, so I don't know why this is 0, but it's written here as per the National Plumbing Code that there's no requirement for urinals. I think maybe they consider that you can use the water closet also for urinating. But I just don't understand the wisdom for this one. Because for when you say malls, they are also considered as commercial establishments. So I think it's not required as per here the National Plumbing Code, but in actuality, I think you may need to provide. Okay? Then slop sinks, last, is where janitors clean and leave their mops. It's made of precast concrete, cast iron enamel, or concrete with tiles. Okay? I think you've already observed this one, especially when you look at your restrooms in your elementary or high school buildings. So you should provide also for this, the slap sinks. This is also important. Then I'm going to introduce you to the scullery fixtures. So when you say scullery fixtures, you have the kitchen sinks. Okay, this is a kitchen sink or KS in your plumbing plan. So it's made of cast iron enamel. Its form is still coated with porcelain enamel and or stainless steel. Then the configuration is single, double, or triple well. So here, as you can see, this is a different configuration. Okay, so you have two uh, basins here for washing. Then you have second, the laundry tubs. So it's just made either cement or cement with tiles or porcelain. Then you have the bar sinks. Okay, example of a bar sink. Okay, then you have the different lavatories. So okay, this is the wall hung. So when you say wall hung, it's something that's in the wall. You're going to hang that in the wall. Then you have the pedestal type. So this is a pedestal type. So it looks like a pedestal. Then you have a counter or Pullman lavatory. So if this is your countertop, that's where you're going to place your lavatories. Okay. So, but then there are several classifications of counter lavatories. So the first is flush. So when you say flush class, when you look at it at the top section here, so it's clean. So it's really flush. So you won't see uh, any protruding part of the uh, lavatory. So it seems like it's very, we call this neat at the top. Okay. When you say self-rimming, so there's a small portion here going at the top. Okay. And when you say under counter, it's really under the counter. So what you see in the top view is only majority would be the countertop. Okay. So this is the countertop here. So you have your lavatory here. It's really can't be seen. Okay. Then let's look at the bathing fixtures. So this is the fixtures you're going to use when you take a bath. So you have your bathtubs, you have your whirlpool baths, you have your bidets. So when you say whirlpool baths, so it's with a removable panel of sufficient dimension to access pumps. You have the bidets, a fixture that appears like a water closet but is more like a tub. It's used to clean private parts after using the water closet. So I think women are more familiar with this one, the bidet. So similar to the distancing of water closets, and so the bidet from side to wall has a minimum distance of 0.375. Then the center to center is at 0.75. Then you have the jacuzzis, which are luxury type bathtubs. Okay. Then we have floor drains, the approved type hinge strainer plate having the sum of the areas of the small holes for the waterway equal to the cross-sectional area of the tailpiece. So provided integrally a past water stop outside of flange around the body at mid-depth, and then inside caulk outlet to provide a watertight joint in the floor. Then what you have what you call shower receptors. This is a receptor floor drain at less than 2% slope or more than 4% slope. Threshold shall accommodate a minimum 550 millimeter with door. So for wheelchair use, dam or curb will be eliminated. You have the shower compartments is made of alternative enclosures of shower, which has a minimum interior area of 0.60 square meters and will be capable of encompassing a 762 mm diameter circle. Okay. So it's a 762 diameter class, so that you should still have enough area for you when you are standing. This is the minimum. So don't go smaller than this one. Otherwise, it would appear to be a very claustrophobic space. Then this area should be maintained from one point above the shower drain to a height of 1.78 meters with no protrusions other than the fixture bulb, shower head, and safety grab rails. So drains for gang shower rooms should be spaced not more than 4.9 meters apart. So let's stop our lecture for this one for the water closets only. Okay. Okay, so then let's now move into your PIP. So I'm going to show you first the plans that you're going to do. Okay, let me just move the screen here. Okay. So I'm going to post this class, the link for the drawings in our uh, group respective group page for the different sections. Okay. So when I when I when I look at uh, the invitation, I think majority of you want to copy instead of designing your own plumbing system. It has also its merit and its drawback. One of its drawback is that you won't be able to experience to design your own, but the merit is that you'll know how to do it properly. So from an actual project. So this is for those from my building tech classes 2A and 2B. You could also access these drawings. Okay? So if you do good here for your plumbing, I'm going to include that in your grade also for your building technology 3. Okay, so this is what you call the ground floor sanitary layout. So what's important as one of the important is that you be able to locate the site or location of your project. Then this is the sanitary plan. So when you see sanitary plan here, you will show the connection from your water closet to the septic vault or SB. So you have here your water closet. It's going down here. Then it's the inlet. Okay. This is the clean out. Okay, here is the vent through roof. And we have a floor drain. So you could see that the water coming from the lavatories, the floor drains, different floor drains, it goes to the catch basin or CB, going to the street drainage. Okay? While those from what you call this from the soil system, especially with feces from the water closet, it goes to the septic vault before it is released the street drainage. So it is purified first here. So it has a different line. The same can also be said regarding the from the downspouts. These are downspout. These are catch basin. So it goes here, different system. Okay. Then the water from kitchen sink, it goes also to a different uh, system, not directly to the septic vault. Now let's move to the next. So this is the second floor sanitary layout. So you can see here at the side, you can see the different legends. Here you can see the symbols and then the meanings. Okay? So try to familiarize yourselves class here with the legends because sometimes even this might come up in your board exam. Okay? So you can see here your water closet. So it goes to a different system. Then your water line layout last, it's also different. So this is the water from the water district. So I think it's easier for me. It's easier to make the details for the water lines. It's mostly just the straight lines. Then you have to provide water for your kitchen sink. You have to provide water for the water closet, for the flushing, for the faucet, and for the shower. Okay? And if it requires in the design, you could also add a jet pump. So going up. Okay. This is the second floor water line layout. This is how is it laid out here. Okay. Then you're going to show also the roof downspout layout. This here. Then this is the catch basin layout. Then is what you call the isometric, the storm drainage isometric. Okay. Since this is the drawing is too big to be represented the drawing, so it places it sideways. But as much as possible, plus if you could do this, uh, present it uh, like that in a manner that when you open the plans, you can see it directly without moving the blueprint or sheet, would be much better. But I think the paper got too small, so you will hardly see the details if you're going to do this like that. Yeah, so this is a much better waterline isometric diagram. If you're going to show the second floor, show the ground floor, then how from the plumbing waterline fixtures interact with each other. Okay. And here we're going to write the plumbing notes. So the plumbing notes, usually these notes come from the National Plumbing Code. Then here you're going to place the different details, such as the details for the catch basins, section, the grease trap, then okay, the planner section for the grease trap also. Okay. Then we have here the septic vault plan. Okay. This is an example. So if this is the inlet glass, I think this is also considered as a three chamber also. When it comes here, the water, the waste comes from here, the pieces, it goes to the here, and it filters again. Therefore, it is released to the drainage. So from the digestive chamber to the leaching chamber. So this is the digestive chambers, so the two leaching chambers, which are much more smaller compartments before being released to the street drainage. Okay, so I think these are the most important parts of your plumbing. Okay, so I guess to reduce your loading, as far I'm going for the first half for the midterms, I'm going to require you to do the ground floor sanitary, and then the second floor sanitary, the water line layout, and the second floor water line layout, and the roof downspout layout. Then the rest of the items, we're going to do that during the finals. We're going to submit this one during the finals. Okay, so I hope you're going to submit something that which is of high quality class, because I would really appreciate that, because you're studying architecture. So therefore, when you present your plans, it should be easily understood, but it should be technical as well. So this is something that appeals to both laymen and technical people in the site. Okay, so if you have any further questions or inquiries, you can contact me anytime and I'll respond. Okay, so last, I encourage you to make questions by commenting on our Facebook groups or by sending me a private message. Okay, so see you next week and stay safe. I'm posting this video along with the link of the different files um, this week.